Okay, sorry. So this question asks us to find the area of the largest rectangle that can be inscribed in a semicircle of radius 4. So let's start by drawing a picture. Of a semicircle. And I'm horrible at drawing these, especially on this little board, but imagine that's a semicircle, and I want to inscribe a rectangle inside of it, so it looks something like this. Now, the rectangle would have to be symmetrical, so of course, if this is x, this is x, and the height would be y. So we can immediately see that the area, which is our primary equation, would be the length of this would be 2x times y. Now, we need that's our primary equation. We need a secondary equation. If you recall from Math 1 or Math 2, again, not sure where they teach this anymore, that the area of this the area of the semicircle, formula for the circle would be x squared plus y squared equals 16. That would be the formula for this. Or we could say that y squared is equal to the square root of 16 minus, I'm sorry, I'm doing that wrong, aren't I? You guys have to say something when I do it wrong. So y squared would be 16 minus x squared, or y is equal to plus or minus the radical 16 minus x squared. Now, because it's a semicircle and we're only dealing with the first two quadrants, we don't have to concern ourselves with the negative. So we could say that y is equal to the square root of 16 minus x squared. So the area formula that we need to maximize is going to be 2x, the square root of 16 minus x squared. Okay? So we have to take the derivative of the area with respect to x. So that gives me, using the product rule, I do have to use product rule on that. There's no way around it. I have to do 2x times the derivative of 16 minus x squared, which now I have to use chain rule. So I take the derivative of the inner function, negative 2x, over 2 square root of 16 minus x squared, plus, keeping the second function the same and taking the derivative of 2x, I get 2 16 minus x squared. Okay? Lots of stuff going on here. Simplifying this, I get this 2 and this 2 would cancel each other out, and I would get 2 negative 2x squared square root of 16 minus x squared plus 2 16 minus x squared. Now, I'm going to find a common denominator in the midst of this beautiful problem. And finding a common denominator, I get negative 2x squared plus 2 times quantity 16 minus x squared all over radical 16 minus x squared. Most people, where you're going to get lost is in the algebra. The calculus you could do. So you could take the derivative of this. It's the algebra that's where you're going to get lost. From personal experience, that's what I found. So simplifying this, I get negative 4x squared plus 32. I said 32, but wrote 36. Over the square root of 16 minus x squared. So once again, finding the 0 of this, solving for 0, I want to see when is the numerator 0. And that's going to give me when x is equal to the square root of 8. Once again, of course, that would be plus or minus the square root of 8, but since x is measuring a length, it can't be negative, so I'm going to say it's x is equal to radical 8. Now, in a problem like this, and also, we would also have to look at when x is equal to 4, because when x is equal to 4, that's when the denominator is 0, or where the derivative is undefined. Now, in a problem like this, I'm going to be too lazy to check to see if this is a max or a min, and I'm just going to take it for a max or a min. If this is a free response question, you would have to check to see if it's a max or min. I'm just going to be lazy and not do it, and because we've all bogged down in this, I'm going to say my answer is x equals radical 8. How do I know my answer is not x equals 4? Well, I could not be inscribed in this rectangle, in this circle, if the length was 4, it wouldn't be a rectangle, it would just be a line. Because I couldn't have any link to that and be inscribed in that circle. So x equals 4 is outside of the domain. So I'm going to say that x is equal to the square root of 8. And what was the question? The question was find the area. So if I have to find the area, I have to solve for y. So then y is equal to the square root of 16 minus 8, which is square root of 8. So the area is radical 8 times radical 8, and the area is 8 units. Okay, that's it for example number 4. Come back for example 5.